2005 higher level question 2. So this question is on Snells Law, where we were asked to verify Snells Law using the table of results, where a student measured the angle of incidence and the angle of refraction, where a light ray was entering a substance. So the first thing it asks us to do, if we say number 1, is to describe with the aid of the diagram how the student obtained the angle of refraction. So we would draw our diagram showing our ray box and a light ray incident on the glass block. We would trace the light ray using a ruler and draw the normal perpendicular to the glass block. We would measure the angle of incidence using a protractor. And the angle of incidence is the angle with the protractor between the incident ray and the normal ray. We would then trace the light ray emerging from the glass block, and then we would lift the glass block and we would connect the incident ray to the emergent ray. And by connecting those 2 points, that would give us the refracted ray. We would then measure the angle with the protractor between the normal and the refracted ray, and this would give us the angle of refraction. So really important to state the use of the protractor, and that it is the angle between the normal and the refracted ray will give us the angle of refraction. But you would have to state that you trace the incident ray, trace around the glass block, trace the emergent ray, lift the glass block and connect the 2 points to draw the refracted ray, and then use your protractor to measure the angle. So you have to go through all of those steps to get your full 9 marks. So step 2 says draw a suitable graph on graph paper and explain how your graph verifies Snells Law. So first of all, we have to see our table is given to us in terms of I and or, but for Snells Law, what we're going to have to do is we're going to have to change this table of results into sin I and sin or. Okay, so the first thing we want to do is check our calculator is in degrees. And then subbing into our calculator, we're going to start with sin 20. So if we get sin 20 in our calculators, we're going to get 0.34. So I'm going to write each of my answers correct to 2 decimal places. Sin 30 is a half, so 0.5. Sin 40 is 0.64. Sin 50 is 0.766, so correct 2 decimal places, so 0.77. Sin 60 is root 3 over 2, so again correct 2 decimal places is 0.866, so we have to round that to 0.87. And then sin 70 is 0.939, so I'm going to round that to 0.94. And now we do the same with our angle of refraction. So we'll have sin 14 is 0.24. We have sin 19 is 0.33. Sin 26 is 0.44. We have sin 30 is a half. We have sin 36 is 0.59. And then we have sin 40 is 0.64. We would have had 3 marks for getting our values for sin I and sin or. So then if we draw our graph of our points, we would have to make sure that we label sin I and sin or on the x-axis, and we'd say or is in degrees, and same here on the y-axis, I is in degrees. Okay, so you're getting 3 marks for drawing and labelling your axis, and then 6 marks for plotting your 6 points correctly. And then, of course, we have to do a line of best fit. So by doing a line of best fit, we want to make sure that it's a line going through the origin, so we have an even distribution of points on either side. And therefore, we have 12 marks for our graph. sorry, 9 I should say, because we already had 3 for getting our points. So we have 9 for our graph. And then how does it verify Snell's law? So we say it's a straight line graph through the origin. Hence, sine I is directly proportional to sine or, which verifies Snell's law. Okay, and again we would get 6 marks for that. So now it says, well, from the graph, right? So that means you can't use the formulas, you have to use your graph to find the refractive index. Well, to find the refractive index, what we're going to do is get the slope, because the slope is the y-axis over the x-axis, which basically means that the slope is n, because that's sine I over sine or. I cannot use sine I over sine or. Please do not use rise over run. Please take 2 points directly from your graph. So let me pick 2 points on my graph. So I'm going to go with this one here. So out to 0.3 and up to 0.42, 0.44. And then I'll take another point on my graph. So I'll go with this one here, which is out to 0.4 and up to 0.6 approximately, okay? So we'll take our 2 points and we'd say our slope is y2, 0.6, minus y1, 0.44, over x2, 0.4, minus x1, which is 0.3. And therefore our slope is our refractive index. Gives us a value of 1.6 for the refractive index. Oh. Okay, and again there was 9 marks for that. So using your graph, so you had your slope, substitution, and your answer. Okay, so the last part of the question then says, well, why does the smallest angle of incidence chosen was 20 degrees? Why would smaller values lead to a less accurate result? So a smaller value of, so if I is smaller than 20, then that means that or is less again, because obviously the refracted ray will bend towards the normal. And if it's going to be smaller than 20, that makes it harder to measure. So if it's harder to measure with the protractor, then that's going to increase our percentage error. So it increases our inaccuracy. And percentage error. Okay, and that was 4 marks. Sorry, that should be 2 C's and 1 or.